First of all, thank you, Eric, for your lecture. It was very interesting, and thank you all of you for joining to this lecture today. I'm very exciting, but let's get started. So, my name is Kim. I'm working for the past year and a half at the Cloud team, which is the first and the best FinOps company as a service. Is the best FinOps as a service company here in Israel. And today we are going to discuss about Kubernetes, a topic that probably most of you heard about it. Some of you know more about, some less. Um, but I know that some of the time this issue can sounds a bit technical, a bit complex. And if to be honest, at the beginning for me, Kubernetes heard first of all like a very funny word. Let's to be honest, and second of all like a kind of a good Greek dish. But all of us know that Kubernetes is actually a platform that allows scaling and flexibility. And I remember that at the beginning of my way in the FinOps world, I heard a lot of people discussing about it, trying to understand how it works, how it develops. And I knew that I wanted to understand much more than that. And of course, to understand how it affects our cost. So today we discussed about the relationship between FinOps to Kubernetes. How can we bridge the gap between the finance world to the development world, and how can we manage the cost wisely without hurting not the performance and not the innovation. So before we will start, I wanted to show you that the monster is not that scary. So let's try to simple things up. So let's think of Kubernetes like a kindergarten teacher. The teacher is managing a class full of Lego blocks. Each child, which we have 5, represents a developer, and each tower they build represents an application. The teacher, which is a reference for Kubernetes, if you didn't get it till now, make sure that every child gets the right blocks that they need, that no one breaks someone else's tower, that if one child is leaving the kindergarten, she taking the Lego blocks and she divided evenly between the demand that each kid is needed. And basically, she makes sure that everything works in harmony. So the same as Kubernetes. Kubernetes, in a simple terms, is a smart system for managing containers. It's like the brain behind how our containers is running. It helps us to deploy everything in a automatically way. It's balance the load. It scale things up and down when needed. And as the kindergarten, she makes sure, and the Kubernetes make sure that everything work together in the proper way. As all of us know, Kubernetes give a lot of flexibility. Our app can run anywhere and at any time, and it brings a lot of challenges because when everything run in a automatically way, sometimes the cost will run automatically too, and we see it at the end of the month in the invoice. So now that we understood what is Kubernetes, let's talk and see the basic structure of Kubernetes cluster. So here in the diagram that I'm sharing, you can see a Kubernetes cluster that's made from several servers. The servers called nodes. In each node, there is a smaller unit that the name is pods. The scheduler decide which node will run in which pod will run in each node, and the kubelet it's the one that makes sure that everything running together. So basically, there is a big system. This is only few of the resources that inside, but it's managed a lot of small units into the one big cluster that we know as Kubernetes. But now we are going to the main of the topic of this presentation, because now that we understood how the code is run, now we need to think how it look at the end of the month in the invoice. So FinOps meet Kubernetes in those 3 pillars. First of all, we have the financial side. FinOps brings visibility and FinOps brings control, and it helps us managing the budget, to forecast the cost, and actually even measuring the ROI on the basic level. It allows us to translate the infrastructure activity to a clear cost at the end. And sometimes this is thing that Kubernetes is not providing us. And this is one of the pain point that I will discuss in the next slide that Kubernetes have with FinOps. The second pillar that we have, it's the performance. It's about optimization the resource. It's about making sure that the response time will be faster, and we want to ensure that the scaling decision that we are doing are not only automatically, but they are also efficient, not only in the technical way, but also in the in cost-wise, that they are cost-aware. In the performance layer, FinOps add another important things that help us to see the workload if it runs in efficient way and not just technical. Then we go to the last pillar that we have, which is the governance. This is the final piece, and for me, this is the one that sets the role of the games. It's establishing the policy, it's ensuring that we have compliance, and that we define the ownership model in the correct place. But basically, in governance, we are here to help to align all of the teams. If it's the DevOps, the finance, the business team, everyone under one single framework. So everyone speaks the same language and share the same accountability. With this foundation, we can make sure that there is one ecosystem, both for FinOps and for Kubernetes. So we know that the main goal of FinOps, not the only one, but the main, is saving. But there is a lot of pain points that preventing us to achieve this goal. And I will start by introduce the first one, which is the lack of transparency. In Kubernetes environment, most of you that tried in the past probably know that cost is not tied directly to a specific app or to a specific person. They are tied to a cluster, to a namespace, to a workload. And when we will receive the bill at the end of the month, it's not will be always clear to us who generated this cost, who this cost belong to. And actually, if I will want to come and show some finger point about someone, I cannot find the owner that say, yes, this is my cost, and this is I'm going to optimize it. And this lead me to the second pain point, which is the responsibility gap. So we know that there is a lot of teams that integrate together in the cloud. We have the dev team that deploy the workloads. We have a team that manages the cluster, and of course the finance team. But they are in the end of this chain. They are receiving the total cost at the end of the month. But without a clear ownership, the optimization fell between the chairs. So for me, the lack of transparency and the responsibility gap, it's like the egg and the chicken. It's not like one come before the other, but they are tied together. Then we have the third pain point, which is the hidden infrastructure costs. We know that Kubernetes is dynamic and it's flexible, and it creates and removes resources all of the time. It's not, it's volumes, it's a load balancer, and each one of them has a cost. And many times, if not most of the time, this cost is not clear and is not shown in the application level. So basically, the pile up in the background, and we can see the cost of them only in the end of the month, or if we have luck, if there is kind of a spike that we can deduct. The fourth pain point will be the incorrect resource configuration specific for request and limit. So Request and limits are very critical in Kubernetes. If we will set the request too high, which means we'll assign CPU and memory to a pod more than it's needed, so the node will save this specific minimum place of the pod inside the cluster. And if another resource set will want to implement inside, we cannot achieve that because the node saved this specific place as the request for the pod, and then we have a wasting of resources. On the other hand, if we will set the request too low, our app will not succeed to run with this minimum CPU and memory, and few outcome can have. First of all, the workload can crash. Second of all, our app becomes slower. And third, an auto-scaling process will start, more node will add, and in all of these cases, first of all, it's unnecessary, and we have unnecessary cost that will cause, and second of inefficiency. So in the incorrect resource configuration, we can even double the cost at the end of the month. So this one is very important to note. And lastly, and for me this is the key, and I think that this is the reason why I became a FinOps, it's the language gap. Because when developers talk about pods, about namespace, about deployments, the other team, which is the FinOps and the finance team and etc., talk about budget and commitment and ROI utilization. And somewhere in between this conversation, the translation stopped working. No Google Translate for them. And when you cannot connect pod behavior to a dollar value, it will be very, very hard for you to have accountability and optimization. So this is, for me, the main Kubernetes pain point that I'm dealing with, and I assume that most of you also, those are your top 5, or maybe you have other top 5, but those are the main pain point that we have. And this is the challenge. But when there is a challenge, I think that it's where FinOps can bring most of their value. And this led me to the next slide, which is the continuous tension that we have between Kubernetes and between FinOps, because FinOps focus on control and predictability, but Kubernetes DNA is built for speed and flexibility, and the challenge is that each one of them is pulling to the other direction. One wants control and the other wants scaling. And our goal as FinOps is to find the balance in the middle. We need to keep the visibility and the control of the FinOps without slowing down the innovation. This is what we needed to bridge between FinOps and Kubernetes. And the way we can reach to that balance, it's not something that will happen overnight. It's not like we are waking up one day and we are fully optimized. It's a journey of maturity. And in the next slide, we will later. Yeah. And in the next slide, we will see how this journey looks like. And for me to take a break to take a sip of water, so sorry for that. Okay, so every organization goes through a stage of maturity. We are learning step by step how can from simply see what is going on with the cost to manage it eventually. And when we look at the maturity level of crawl, walk, and run, at the core stage, everything is still very new to the team. They are just starting to gain visibility. They might have basic dashboard, maybe some tagging, few reports here and there, but not something I think that it's big or more than that. But the main goal At this point, it's simply understand what is going on inside, nothing more than that. Where the cost is coming from, which cluster, from from which namespace, is the workload that we have. And so it's less about control and more about building awareness. Then we are going to the second stage, which is the work one, which is the work stage. Sorry. Things start to become more structured at this stage, and standards begin to appear. So basically, instead of everyone deploying workload however they want everywhere, teams start to use pre-approved templates. In those templates, they are defining the right configuration, the right CPU, memory, request, limits. It's like giving a developer a smart starting, that they're already part optimized with performance and with cost. So this alone can prevent a lot of over provisioning and unplanned spend. Um, Also in this stage, teams start to use the spot instances, but now they can do it more wisely and with a strategic way. So instead of just switching everything to spot and hoping for saving, the decision of the spot come with a lot of knowledge. The workload that they will choose will be a workload that can handle interruption, like non-production, like a non-critical workload. And also, because we are talking about spot, they need to, and they will implement an automation in place that will handle a spot instance that just reclaimed. And finally, after the crawl, after the walk, we are here with running. And in the run stage, things eventually and finally start to click up and to sum up to one core. At this point, FinOps is not just a process that's sitting on top of the engineering team. It's embedded in how the organization is operate. So the big shift here is around the code efficiency, because at the end of the day, I know that with FinOps we came and we correct the scaling, and now we are doing it perfectly. The auto scale work well. We balance all the workload. But if we do all of that, it's not mean that we fix the code and that the code is efficient. So if our application is not written in a way that consume the exact CPU and memory that she needed, Kubernetes will give the same CPU and memory to the same app, which means at the end of the month, this is a waste of money. So developers start thinking about performance and cost together in the run stage. They fix the inefficient queries, they cache the data, they optimize the loop, and suddenly the app change. It's run now faster, it uses less resources, and again, the cost is reduced. So in this moment, I believe that FinOps stopped being a financial decision, but it started becoming a culture one. So we basically run from the crawl, which it's the infrastructure, into the code itself, from visibility into full control and optimize step by step. And now that we see and understood the maturity level and the maturity develops, I would like to show you and to sum it up under the best practice that we have. Okay, so basically it's summarize the main point that we discussed about in the organization and maturity. It starts with the pre-approved template. We are creating standard workload. So every deployment follow the same resource and the same cost rule. Of course, that important note to say, the pre-approved template will be suited to a workload that operate and work the same with the same outcome. Then we have the right size everything, and here we make sure that the node size, the scaling policy, the request, the limit, and everything is avoiding over provision, that everything is suited to the actually usage that our app is needed. For me, and I assume that for all the FinOps that's now in the session, visibility dashboard is not something that is imported to Kubernetes. It's something that is actually, I feel, our core. So use BI tool, use Grafana to track the cost and the performance in real time. You can get a lot of insight for that, not only for the cost, but for KPI and another cost optimization idea that you have. Then we have the strategic spot usage. So using spot instances smartly on non-crucial workloads. I mentioned it always also before. And of course, don't forget to create a plan for fallback in place. And finally, the tagging. Tag everywhere, every namespace, every resource. So all of your costs can be tracked across all of your team. This way we can prevent the lack of transparency and the responsibility gap, which we discussed at the beginning of the presentation. So this sums up the best practice, but we know not everything goes always as we want, but we have also some pitfalls to avoid when we talk about Kubernetes. So the pitfalls to avoid will be, first of all, over-provision the workload. Again, where CPU, memory, requester, and limit setting too high, we are wasting resources, and that's how we can increase the cost, which is something we want to avoid. The second will be too small VM type. So when pods start up and spin up, usually they need more RAM. When we choose too small VM type, when the pod will start up, some of the time it can the amount of the request inside will not be enough for the existing node, and another node will need to be created only for the startup of the pod. So maybe instead of having too small VM, we can change the VM type to a much larger VM, and this way maybe we are using a different SKU and a much expensive SKU, but we have less node comparing to a smaller VM with much bigger amount of node. The third pitfalls to avoid would be the over provisioning storage. So for example, in Azure, when you are creating a cluster, there is the default disk size for your operating system. And this size is not necessary most of the time to your requirements. So my comment to you is to check if the OS is fit to your requirements, and if not, change it. I know that a lot of organizations not aware to that, or just like create a cluster without changing this configuration, and trust me, this can save a lot. And another two pitfalls that we have, the unlimited auto scaling. Of course, if we will not set a limit, our cluster will increase and increase and increase without stopping. It will create cost spikes and application error, and it's something that we want to avoid. And lastly, expensive spot instance. I know it can sound a bit weird, but when you're using spot and the eviction rate will increase every day, every 2 days, it can cause your application to crash. And every time when you have crash in your application, it spend time, is spend money to start everything up. So make sure that you're choosing your spot instance according a low eviction rate. Um, and let's go to the next slide. So before I will finish, I would like to show you a few real world examples from our customers. It's very small, but I think it's very important to show some real cases that actually saves money. So first of all, the rebalance node. So a rebalance is a process when we are consolidate all our node into one. I will give an example. For example, if we have 3 nodes, each one of them using 20% of the total CPU and memory. When we run the rebalance process, everything will consolidate the 20% and the 20% and the 20% into which node. So from 3 nodes that we are paying to, now we have 1 node. So first of all, this is cost saving. Second of all, it's optimize also the performance, and it can reduce the cost by 40% of the previous one. And the second example that I have is the PVC migration savings. So in one of our customer, we shift from a PVC using data disk to a PVC using storage account, file share, if to be more specifically. This change, again, improve the performance and reduce the cost by 20%. And as we all familiar with ARM processor, the Graviton is the one that is the most familiar to us in AWS. So transitioning to ARM processor actually can improve the performance. It will reduce the power it will reduce the power of the consumption, and of course, we lower the cost between 12 to 50%. So now that we are about to end, and I know that we have another 1 minute, but if you have a question, this is the time for you. And
yeah, thanks a lot for the talk, Kim. I think it was great. Kubernetes is something that I like a lot because I basically work with it every day, and it's very tricky to deal with it in FinOps. So any questions that you have, leave it please in the Q&A section. There is one already from the beginning of the talk, which is like, what's your perspective on using, in this case, Cast AI, but I assume any Kubernetes third-party tool for the optimization?
I think that it's not a specific topic, and I would like to understand it to answer it fully. So if I can take it with you offline, it would be great because I have a lot to say about it.
Cool. Yeah, thanks for that. So Sachin, please reach out directly so you can get it from there. And regarding the recordings, of course, there will be a recording sent after the event once we finish both days. During the weekend, I will try to do so, to send it to you all. So one interesting question from Jose Antonio is that could affect is the new policy about the 5-minute cost for short runtime applied by default. Could it affect spot machines and make the cost bigger than even for a standalone? What do you think? Do you?
Where is the question? Wait.
It's in the chat.
Yeah, I can see.
So this new Azure policy for the 5-minute cost for spot instances.
Wait. Actually, I didn't heard about this policy, so it's the first time that I saw that he sent the link also.
The link.
I
So you
didn't heard
can
about it, but it's very interesting.
maybe maybe Jose Antonio, if you can put the question in the Q&A side, and then
Okay, that would be great.
maybe Kim can take a look at the docs and answer you properly, because yeah, this would be really important to anyone using Spot instances, and
Yes.
especially for Kubernetes workloads. If you use small ones, I can subscribe to that recommendation. That unless, well, probably if you use small instances, you probably can leverage serverless or any other stuff for your Kubernetes workloads, but you should use nodes that are considerable for your workload, because if, especially if you use sidecars such as, Argo CDs, Grafana's, any monitoring system, if you have more nodes, it means more sidecars. So it's something that I learned the hard way, because I got nodes spotting every time because of my monitoring, and my monitoring was even higher than my node requirement. So something that you don't want to have in your FinOps spotting, because you will have probably infinite nodes. So definitely take a look at that. And do you have any comments on the question that does Sam about RI and management for Kubernetes? What are your thoughts on there?
Um, Actually, when in most of our current environment, we are running Spot.
Mm-hmm.
So using RI with Spot, as you know, it's not the best suitable way. I assume that if you are not running Spot, RI definitely can be something that you can that can be efficient. Again, you need to combine it with what the organization is planning to do, for how much you're going to use the RI, and of course to see if you benefit from it at the end.
Yeah. Kubernetes, it's difficult to measure
Yeah.
the RI unless it's a very basic part, or a very base percentage. Then you should leverage a spot for the flexibility of that. Of course, if you have critical workloads and you are not going to be decreasing for certain amount of consumption, you can
Mhm.
have that covered in RIs or savings plans, and then leverage a spot for the flexible thing. Okay, let me see if there are
Interesting.
any.
Oh, sorry.
No problems. What you were? It's better to use savings plans, which
Savings
is more
plan.
flexible. Yeah,
Yeah.
savings plans fits better, I think, the Kubernetes style in general, I would say, definitely. And is cubed cost a good tool to solve problems that you mentioned? So, not sure if you have thoughts on the tool, or maybe you can dive into that more personally if you want. Okay, so okay. Thanks, Jose Antonio, for clarifying the question. I'll let later the rest of the people to answer that. If someone has already any insights on that, I haven't read that, so I'm going to take a look at that definitely, and see what, because this would be very interesting for people using Azure. Because if they get built that short, it's going to be a little bit crazy. So I'm going to mark this as solved, and I'm going to move to next. But beforehand, I want you to show again some love to Kim, and we are going to start with the survey. It's always nice
Thank you, Victor. We
to
could just, I can see the question here. Okay, thank you. I just want to
yeah, feel free
react.
to take a look and answer it. And now you can rate the talk by Kim. I think it was a great one. So thanks, Kim, for
Thank
part
you.
participating. It was a pleasure to have you over here.
It was a pleasure to be here. Bye bye.